Welcome to episode 5 of the Bomberman series. It's been a really long time, I know, but I've recorded this video 3 times already, and 3 times there's been an issue. The first time there was no sound, second time there was some glitch in the video, and the third time again, no sound. So finally I hope to finish this video, get it out to you, and then start making some new videos. I was actually gonna make a video about restructuring some parts of the application, but I feel like I've done that a lot already. And a mate of mine asked for a video about collision. So that's what I'm going to give you, a video about collision. Now collision is quite a big subject, so I'm going to split that up into 2 videos. First video will be implementing the basic collision system, and then the next video will be extending that to work with all the needs that our application has. Okay, so what we'll do this video is we'll have a single box, a single test entity, which will be collidable, and the player will collide with that entity. To start off with, first of all, let's talk about where we want our collision to happen, right? We have our player, for example, but our player is not exactly the size of what we render, because we render our player sprite as being, where is our players? We render our player as being this width, which is pretty sure 64, 128. So it's 2 blocks high, 1 block in width. But as we can see, if we just stand on some block, then we can clearly see that the player isn't exactly the same height as 2 blocks. So we want to have a custom bounding system around our player, which signifies where exactly the collision should happen, which is exactly what we're going to do. But how exactly? Okay, we'll start by defining a collision box, meaning which will be exactly that. Like this will be a bounding box around our player, signifying where exactly the collision should happen. Because in our game, since everything is a square, we're kind of gonna just make square collision, only square collision detection. We might add circle collision detection later, which is not that hard. But let's stick with square collisions detection. We'll have we'll add that in a different folder, because like I feel like there's so many things already in this folder. We will start to structure things in folders. Like sprite can be in a different folder and so on, you know. And this will be an interface. There's no need for it to be like an actual class. So we'll need an expos. Okay. Which will basically say, this is where not my entity is drawn, but where my collision is drawn, let's just say. Now, we'll need to, when a collision happens, we have 2 things, because not every entity, not everything can be collided with, right? For example, the grass I'm walking on, there's no collision on the grass. So, what can be collided with is, for example, a brick. Well, I don't have a brick right now, but I'll add one. Well, let's just add one real quick, actually. Test entity. Which will be a class brick, which extends entity. Just gonna take a few things from our map. I will need a sprite. So. It's not sprite. Oh yeah, I was a bit confused because the test setup I used still had a different, had the new system already, which I was going to refactor today, but instead I'm doing collision, which is fine. We'll just use this one. We'll get a tile image. We have sprite sheets already, right? One sec, let me check how this works again. Yeah, that's fine. We'll use a sprite sheet. Sheet equals. I don't really know where I've used the sprite sheet so far. In the player probably. Yeah, that's what we need. With this sheet. Sync image utils. Load image from URL, and this will be the URL of blocks. Blocks.png. I'm sorry, blocks.png, that will be the image, and sprite sheet will be defined as such. Sprite sheet image with image, and this is 64 by 64, and then when we render, which we can actually just generate. We render, we go this dot sheet render game data x. We want the sprite at position 1 0. We want to draw it at, let's say 100. No, we can't go 128 with a width of 64 and a height of 64. That's that. And we forgot to add the entity to the actual game. We will add entity new test brick. We want to add it before the player, so the player gets drawn last, which means the player gets drawn on top of everything else. One thing I noticed, I've already fixed. I thought I'd already fixed this, but for some reason I've called this Bomberman game. Which should obviously be Bomberman game. Bootstrap will. There we go, Bomberman game. This is interesting. Now I get to look at most of this with like fresh eyes. Okay, so now we have our test brick, and it should be drawn. There we go. It is drawn on the screen. Now, obviously, we can just walk around it, walk over it without any trouble, which is not really what we want. So what we're going to do is make things collidable, right? Because, yeah, exactly, sorry. Once again, there are two things in a collision. There's the driver, which I call the driver, is the one that collides, the one that moves. Obviously, you could have two things moving, but the one that tests for a collision. And then you have all the things that he could collide with. Say, for example, you have a player. You test for all the things the player could collide with. For example, this block. Say you have a projectile. Test for all the things the projectiles could collide with. So that could be, for example, the player itself, or another brick, or a wall, or like something. So that's how we're going to structure it. Always have these two parts separated. And the thing that can be collided with, we call collidable. Which is an interface which gets has a single function get collision box. Why can't I? Oh, there we go. The default collidable. Default collidable. Okay. So now we have our collidable. So we're going to make our test brick collidable. Now we have a collision box in there. Now we actually have to return our collision box, which will be our actual position. Okay, there we go. Let's also make that public. Okay, now we have our collision box. It returns our collision box. Not really a problem. Like if it weren't a test entity, we would define that somewhere so we don't have to recreate an object every time, but it is a test entity, so who cares? And I'm pretty sure that even gets compiled to something like that. Okay, now we need something to test for collision, because in our player we want to be able to say right here, if player, or this, if game data, the collision handler or something like that, that collides, find collision with this dot get collision box, something like that, you know? That's what we want to be able to say. So we need a collision handler. And our collision handler will have a few things. First of all, obviously, our collision handlers should be able to check if two entities, if two boxes collide, if two colliding boxes collide. So check collision. Find collision, I'll just say. We'll have our driver box, which will be a collision box, and then what I'm going to do is I'm going to add a brick, which will be the thing you collide with. Now the brick is not going to be a box, but instead it's going to be a collidable. And the reason why I say that is because I want to return a collision. Well, no, or a collision. And a collision will contain all the necessary information about what the driver collided with, which will be sent back to the driver, in our case the player. So we're going to create a collision, interface collision. Which will contain width, which will be collidable, and it will be top boolean, bottom boolean, left boolean, right boolean. There we go. Now we import collision, and we return null by default. Now, let me just quickly explain how exactly we're going to handle collision. Okay, during the video I explained it so badly, so I'm going to do it over again. First of all, we've got two boxes, right? We want to test whether box 1 collides with box 2. It's quite simple. Now, if we do it this way, then it's not that straightforward. We could just test every point, but fuck that. So what we're going to do instead, in my opinion, the easiest way to like visualize it in your head and to actually implement it is to have 2D collision, 1D collision, sorry. So imagine this being the x-axis and these just being lines on the x-axis, right? And we want to test whether these two lines overlap. So how do we do that? We take one line. So collision is either from this side, here, or from this side, here, right? So on this side, we just check whether this point is between this point and this point, which is easy, right? It's bigger than this, smaller than this. On the other side, we check whether this point is between these 2 points. And that's all there is to it. There's no more shenanigans, there's nothing else. That's how we're going to test collision. It's not exact, because if one of them is really long, you could technically like bug into it, but I find this to be like adequate. So that's exactly what we're going to do. One thing we're going to change, however, is we're going to use these points, this point and this point, to check. And the reason we're going to do that is because it works exactly the same. If we come from this side and we check whether this point is between these two. We come from the other side, we check whether this point is between these two. And that makes it a bit easier in the code because we don't have to add width every time, and a bit more straightforward. So that's how we're going to do it. Back to the video. Okay, so I cut a bit of the video out because I explained it very badly and I wanted to explain it properly with some paint.net skills. So hopefully you have a good idea of what happened. Now, to implement that, we're going to have our left collision, right collision. Let's start with that one. And it's going to be driverbox.xbox smaller than breakbox. We need a breakbox. Breakbox collision box. Breakbox.xbox and driverbox.xbox plus driverbox.width is bigger than breakbox.x. Yeah, that looks right. Okay, let's have left collision, and it's going to be exactly the same, except we're going to switch them around. So driver box will become brick box, and brick box will become driver box. We could also just say driver box xbox plus width smaller than, and so on, but let's not do that. Well, stop collision is going to be exactly the same as these. Bottom, except xbox is going to be white box, and width is going to be height. There we go. And that's really it, to be honest. Like, now we have collision, but there is only collision when one of those and one of those is true. And that's a very important thing, by the way. That's a very important thing, because that means, because without that we would just have a big line, right? We wouldn't be able to move here at all because it's on the same x-axis. The x collision is here. The x collision is active here as well, but we want both of them to be true. So what we're going to do is, if right collision or left collision and top collision or bottom collision, then we're going to return our collision, which will be with brick, and top collision, bottom collision, left collision, right. There we go. So that's our find collision function. Now we're not just going to check on all entities whether they're collidable. We're just going to have only the collidable entities, and we're just going to keep a list of the collidable entities in our collision handler. So the reason why we keep a list here separately is because we don't really care about entities, right? Our collision handler shouldn't really care about entities at all. It should just be collidables. Anything that has to do with collision. That's what our collision handler does. It doesn't give a shit about anything else. Just this. So, we're going to make a function which adds collidable. Collidable. Now, we want our game to automatically add collidables to this collision handler. So first of all, in our game, we need a collision handler, which we're going to put in our game data. Let's add it. Did I export it? I did. Add that collision handler, and in our game, we'll add it to the list. And whenever we add an entity here, when we add an entity, we also want to add that to the collision handler if it is collidable. So it's kind of annoying to do this because we have to check whether it's an instance of an entity. So what we're going to do, and the problem is TypeScript really doesn't handle this well in my opinion. But the best way to do it is collidable entity, and it's an entity, just a normal entity, or it might be a collidable, and it's going to return entity is collidable, which is a boolean, right? But it checks whether the entity is collidable. Now we're going to return entity as collidable dot get collision box is dot equals md5. So basically what it does is it says let's assume our entity is a collidable. Then get the collision box function. Does it actually exist? And that's what it returns. And using this, we can check whether our entity has a get collision box function. And that's how we decide whether it's a collidable. So if entity this dot is collidable entity, then this game data dot collision handler dot add collision a collidable entity. There we go, no errors. TypeScript is happy. So now our entities automatically get added to the collision handler. So we need one more thing, and that is find collisions. Driver box, which is simply a method that you call and it returns a list of collisions. Because you could technically collide with multiple things at once. Let's return, yeah, that's fine. So what it does is basically the collision array, and we return collisions, and I have 4. Let of this of collidables collisions push sorry collidable this of find collision collidable get collision box sorry, what? No, driver box and collidable. What's wrong here? Oh, that's better. Oops. If collision is not known, then we add it to our collision. There we go. And that gives us a list of all collisions. Now in our player, we just have to check for collisions. But we're going to do that in a different function because I don't want to put it here. Right, it's too much shit already in that update function. Check for collisions. And we'll just calculate collisions. Collision. We'll just say this will calculate collisions. Collision. And we're going to pass game data because it needs game data for the collision handler. Now we'll get player collision box. Collision box. The const collision box equals. To make it simple, to make it simple, just make it a collision box, which will have this dot xbox add some spaces because bad at typing today. Okay, now there's another issue. What we want to do is we want to check where the player is going to be and see if that collides and then stop that movement. The problem is, if we do them both at once, then say if we do X pos and Y pos at once and we move over to the right, then we won't be able to move up or down because it will just say, wait, you can't move up or down, there's a collision, right? So that's a big issue. So what I'm going to do is I'm going to test collision twice, once for the X-axis and once for the Y-axis. So for the Y movement and X movement, sorry. So we're going to pretend to move X, our velocity X, see if that hits, if that makes a collision. If it makes a collision, cancel that movement, and then test Y, and then test cancel Y if that makes a collision. So that's exactly what we're going to do. In our collision handler, we're also going to add a method to make that a bit simpler. Test collision test movement collision box we'll make it a driver box, and we're going to need X movement, Y movement. I'm going to return I know what we're going to return. We're going to return this.find collisions with X-pos being driver box X-pos plus X movement, Y-pos being okay, and that should return our collision for the movement that we want to test. So, I don't know if it's 1S actually, but like I've been using 1S everywhere, so I might as well just keep doing that. This is velocity X. 0. Okay, now in the future, we want to test, we don't want to just say this.velocity X is 0. We want to say move for the amount you still can. Because if I can still move like 3-4 pixels, then why wouldn't I be able to move 3-4 pixels, right? It's a small thing, but we'll do that in the future, because this video is already getting pretty long. Move how far you still can. Move the distance you're still. Okay, let's see if that works. Okay, I can still move up and down. There we go, our collision works. There's one thing we still have to do. Yeah, our player is still not the right size. So instead of just saying this, setting this as our collision box, we're going to add and subtract some values. So I'm going to put that on some new lines. Okay, so we're just going to add and subtract some values from this and see where we are. So our Y position, that's like, we need plus 100, maybe more. Yeah, because we want that like this small circle in the bottom, right? That's what I want. You could also just set it here, and then we'll be like minus 20, I think, and then we'll be fine this way. Oh, it's minus 40. They will work perfectly this way, right? But I prefer to have the collision at the feet to give like a bit of an isometric idea. Like it's not just top down, you're looking at it from the side, which is not exactly what we have, but let's just do the best we can with the assets we have, right? So 110 maybe. Yeah, that's the circle, but the problem is we need to set the height minus 110 now. Okay, minus 150, let's just say. Perfect. Now right and left. They both need like minus 10. So let's say x plus 10 minus 20. I like it. That's good. There we go. We have collision working. Okay, thank you for watching this video. There are a few things I want to mention at the end. Next time we're going to keep going with collision a bit, but I also want to get a video in there restructuring some things, because the sprite and the sprite shear system is not great, and I really believe there's a better way. Because the way that I already planned actually for this episode is, in my opinion, much better. So hopefully you liked this video. If you did, throw a like, I guess. I don't know. Thanks for watching. Have a good day. Bye.